We've moved over into a garage to get away from the hustle and bustle of the studio. We're going to repeat an experiment performed by Cavendish more than 100 years ago. We're going to try to measure the force of gravity between a box of sand and a bottle of water. You could repeat this experiment yourself if you wanted to. It's not too difficult. But instead of using just one bottle, we have 2 bottles of water and 2 boxes of sand. Our 2 bottles of water are suspended from a yardstick that you can see. The yardstick in turn is suspended by means of some recording tape, thin recording tape that goes clear to the ceiling. The period of oscillation of this torsion pendulum is pretty slow, about 10 minutes. So what we're going to do is to show you the oscillation of it in stop frame photography at a rate of about 60 times normal. In order to show the angle of twist of the pendulum, we have a mirror attached to it right down here. A light spot is reflected from it, shows it swing on the wall. The period of the pendulum is really 12 minutes, but you see it here in 12 seconds, as the minute hand of that clock shows. And I'll mark the middle of the swing, like that. Now we're ready to put the boxes of sand in place so that they can pull on the bottles. Okay, now we're ready to watch the sand pull on the bottles. It's swinging. And the center of swings is displaced over to one side. And I'll mark a new center of swings. Now, instead of setting the boxes back the way they were originally, what I'll do is to move them around so that they deflect the pendulum in the opposite direction. This will give me twice as big an effect. There it goes. Now it swings over to the other side. And there you've seen the effect of the force of gravity acting between relatively small bodies. Question is this a powerful force? You know that it doesn't take much to twist a piece of recorder tape, especially if it goes all the way from the floor to the ceiling. But it's common to think of gravity as a large force. But you remember that the mass of the Earth that pulls on you is a lot bigger than the mass of that box of sand. Notice another thing. Notice, too, that the glass and the screen wire had no effect, but the screen wire is there for a reason. Watch this experiment. I can charge this lucite rod up here by rubbing it on my sleeve, and pick up a piece of paper very easily. Let's see if that charge, which you proved to be there, see whether that has any effect. None at all. The screen wire shields it out. But let's see what happens now if I very gently lower the case and hold up this charged rod. Practically jumps out of the case. Look at that. The electric force is tremendous compared with the gravitational force. We'd better go back to the studio and look at that electrical force a little bit more. You just saw this electrified rod pull on a bottle of water, just as it does on this ping pong ball. But there's one big difference. I can rub this off. And you can't do that with gravity. Well, one more thing. The force depends on the distance. Watch. Closer I get, the harder it pulls. And one more. Suppose I let it touch. Then it'll repel. And you never saw gravity repel